Hello, welcome to another video on differential equations. Today we're going to be looking at verifying differential equations. Here we have our differential equation, and we have two equations. We're going to see if one of these, or if we're going to see if one or both of these are solution, if both of these are solutions to this differential equation right here. So really, with these type of problems, all you're really doing is you're just plugging in and testing for each individual one. So, for example, we have y1 of t equals e to the power of t, right? So y1 of t equals e to the power of t. Well, we're going to have to go up to the second derivative. This is y double prime. We have y already. So y prime of t here is going to equal e to the t. The derivative of e to the t is just e to the t. And then we're going to have y1 double prime of t is going to equal e to the power of t again, because the derivative of e to the t is just e to the t again. So now we have y double prime and y. So what this is actually going to look like is y1 double prime minus y1 equals 0. And is that true? You're asking yourself, is this statement true? When I plug these values in here, is it true? Well, we have e to the power of t minus e to the power of t equals 0. So that is true. So this is a solution right here, right? So now let's test cosine hyperbolic of t, and we'll see if that is also a solution. So let's try, okay, so y2 of t equaling cosine hyperbolic of t. Right, so the derivative of cosine hyperbolic of t is just sine hyperbolic of t. So y2t equal, y prime 2t equals sine hyperbolic of t. And then y2 double prime of t is going to equal cosine hyperbolic of t. The derivative of sine hyperbolic is cosine hyperbolic, derivative of cosine hyperbolic is sine hyperbolic. So now let's plug this in. We have y2 double prime minus y2 equals 0, and you're asking yourself, is this true? Because this is our differential equation. So we have cosine hyperbolic of t minus cosine hyperbolic of t equals 0, and that is true. So both of these are solutions to differential equations, to this differential equation. So I'm going to do a couple more practice problems like this. Let's see. That's a semicolon. I know it looks pretty sloppy, but it's not a J. Okay. So now we have y double prime plus 2y prime minus 3y equals 0. And we're going to test to see if this is true for both y1 and y2 of t. So let's test the first one first. So we'll say y1 of t equals e to the negative 3t, right? So y1 prime of t, well, we can just use the power rule, but we leave this alone whenever we're dealing with e. So we bring the negative 3 down, negative 3 e to the negative 3t, and this part stays the same. Now y1 double prime of t is going to equal negative 3, the coefficient of this term, times the negative 3 again. That's going to give us 9 e to the negative, it's a little sloppy. It's going to give us 9 e to the negative 3t. So now let's go back. Now that the highest derivative we had to take was the second derivative, because that's the highest derivative of this differential equation. If we would have had a y triple prime over here, we would have had to take the derivative one more time and then plug everything in. All of this right here is going to go back into this equation. So Let's do y double prime first, so that's 9 e to the negative 3t plus 2 times y prime, which is negative 3 e to the negative 3t. And then we have minus 3y, which y is e to the negative 3t. And we're checking to see if this is a true statement, if this equals 0. So we have 9e to the negative 3t minus, because this is a positive times a negative, minus 6e to the negative 3t minus 3e to the negative 3t. And that equals 0. Well, that actually is just 9e to the negative 3t minus 9e to the negative 3t, which does equal 0. So that ends up checking out. So y1 is going to be a solution of the differential equation. Now let's test for y2. So y2 is e to the power of t. So y2 of t equals e to the power of t. So we know how that derivative works. It's just going to be the same all the way down, because the derivative of e to the power of t is just going to be e to the power of t all the way down. Okay, so now y double prime is going to be e to the power of t plus 2 times y prime, which is just e to the power of t, minus 3 times y, which y is just e to the power of t. And does this equal 0? That's what you're looking at. If it doesn't equal 0, that doesn't mean you messed up. It means that that is not, whatever you tested is not a solution. I mean, you could have messed up, but if you're confident in your work, that means it's not going to be a solution to the differential equation. So now we can say that this is going to come together, combine like terms, and make 3e to the t minus 3e to the t equals 0. That's a true statement. So then both of these are solutions to the differential equation, this differential equation. So let's try another one. Practice is always good with this class. So, okay. Okay, so it's giving us an equation this time, or just one equation this time, just y. So let's go ahead and take the derivative of this. So y prime is going to equal 3 plus 2t, right? Because the derivative of 3t is just 3. The derivative of t squared is 2t. So now we're going to plug this in right here and this in right here, right? See if that equals t squared. So we have t times y prime, 3 plus 2t, and then we have minus y, which is 3t plus t squared. And remember, this is in parentheses. You're subtracting all of y. It's not like this. It's not 3t, it's not minus 3t plus t squared, right? That's wrong. You have to put parentheses here, subtracting the whole thing, and then we're going to see if this equals t squared. So let's go ahead and distribute. 3t plus 2t squared minus 3t minus t squared, right? So now we have, 3t's go away, cancel out, and we're left with 2t squared minus t squared. So that is t squared equals t squared. So this is a solution to this differential equation. So I'm going to do one more. This next one is going to be a little trickier because it involves, I think it involves a product rule. So okay. Yes. so all values t are greater than 0. We have y1 of t equaling t to the negative second power. Okay. So now what we can do is take the derivatives, right? So we're going to test y1 first. So y1 of t equals t to the negative second power. So how are we going to take the derivative of that? y1 prime of t equals, well, the negative 2 comes down, and you subtract 1 from the exponent. And then we're going to take the second derivative of it. Double prime t. It's going to be positive 6. Negative 3 times negative 2 is positive 6. And then t to the negative fourth power, subtracting 1 from the exponent. So now let's plug it in. So we have t squared times y double prime, which is 6t to the negative fourth, plus, run out of room. Let's do it down here. T squared times y double prime, which is 6t to the negative fourth, plus 5t times y prime, which is negative 2t to the negative third, plus 4y. Oops. And the y is going to be what we're originally given, right? The t to the negative second power. And we're trying to see if this is a true statement. We're trying to see if it's equal to 0. So now we multiply this in, and we wind up with 6t to the negative second power. And then multiply the 5 and the 2. This is going to turn into a negative. So negative 10 is the coefficient, and then multiply t in. It's going to be t to the negative second power. And then plus 4t to the negative second power. And is that going to be 0? So, well, we have 6 and 4, which makes 10. You add them together, they're all like terms. So 10t to the negative second minus 10t to the negative second does equal 0. So that first term, y1, is a solution to this differential equation. So now we can erase our work, and we can start working on the second one, which is going to be a little bit harder. Okay, so not harder, just more tedious. So start up here. Y, I'm just going to use y of t just because it's going to be easier. Okay, so y equals t to the negative second ln of t. So, there we go. Okay, so now we're going to have to use the product rule here in order to take this derivative. So y prime. Remember, the product rule is just f prime g plus g prime f, where this is f, this is g. So, so let's do f prime. So negative 2t to the negative 3, right? Negative 2t to the negative 3. This is f prime. And then g, so just the second, plus the derivative of the second, which is 1 over t. The derivative of the natural log of t is just 1 over t, times the original f, t to the negative 2, right? And 1 over t is the same thing as saying t to the negative first power. So I'm going to rewrite that as t to the negative first times t to the negative second, and that turns into t to the negative third power. So our y prime value is going to be negative 2t to the negative third ln of t plus t to the negative third power. And now let's do this second derivative, y double prime. So put an arrow to that, so remember to copy over there. So y double prime is going to equal, well, we got to do the product rule again. So the derivative of the first, that is 6t to the negative fourth power this time. Yeah, 6t to the negative fourth power. So that's f prime. Now we're going to copy g down, ln of t, and then plus g prime f. So ln of t is 1 over, the derivative of ln of t is just 1 over t, which I'm going to write that as t to the negative first power. I hope you agree with that. And then we copy down this first term, which is just f, the original f. Negative third. And then can't forget about this little last part right here. So, and this is going to be plus the derivative of this, which is going to be a negative 3t to the negative fourth power. Okay, so let's simplify that a little bit. Y double prime is going to equal 6t to the negative fourth power times ln of t. Plus, this is going to turn into a minus sign. Minus 2t to the negative fourth. And then minus again 3t to the negative fourth. 3t to the negative fourth. So this is going to turn into, we're going to combine like terms here. Y double prime equals 6t to the negative fourth. This marker, man. Use orange instead. Six t to the negative fourth ln of t minus, and then it's just gonna, these can combine because they have the same terms. They have the same t attached to them, so minus 5t to the negative fourth. Okay, so now let's go back and plug each one of these in the original equations and see if we can't get it simplified. I'm going to copy this up here real quick. So I can erase it. Here. Okay, so start with this. So t squared times y double prime. So 6t to the negative fourth ln of t minus 5t to the negative fourth. So that's just this part right here. And then plus 5t times y prime, which y prime is, we'll write it with this term out in front just to make it a little bit more simple. So I'm just reversing this order. So I'm writing the positive first, then I'm writing the negative second. T to the negative third power minus 2t to the negative third power ln of t. T to the negative third power minus 2t to the negative third power ln of t, right? Got it. And then plus 4y. So plus 4 times y, our original y is t to the negative second, t to the negative second ln of t, and we're trying to see if this is going to equal 0. Okay, so let's simplify it a little bit. T squared to be multiplied into here, right, into both spots. So we're gonna distribute this. So we're gonna have 6t to the negative second ln of t minus 5t to the negative second. and then plus 5t can be multiplied into each term, so let's do that. So we're going to have plus 5 do that a little bit. There we go. Plus, so that's 5t to the negative second power. So we're multiplying sorry, these markers are giving me a hard time today. Okay. 5t to the negative second, because anything, I haven't really explained this, is more like algebra, but I'll go ahead and like take a break and explain. So like 5t is t to the first power, t to the negative third times t to the negative third power. Anytime you're multiplying exponents together, you can just add the actual numbers on the exponent. Sorry, my camera cut out on me. So what I was saying about exponents, you just add them like you would like x to the third times x to the fourth is going to equal x to the seventh. You add the 3 and 4. So now let's simplify this, and we're on the home stretch of this. So distributed all that, so now we're distributing this. So 5t times t to the negative third, that's negative 3 plus 1, so we will end up with 5t to the negative second power, and then minus 10t, because the negative 2 and 5 make negative 10, minus 10t to the negative second power, t to the first power times t to the negative third power, right? And then multiplied by ln of t. And then plus 4t to the negative second power ln of t. And we're trying to see if that equals 0. Alarm's going off. Okay, so we're trying to see if that equals 0. So what we get is, well, the 6 and 4 right here, they have the same terms attached to them. They come together to make 10. So 10 t to the negative second power ln of t minus 5 t to the negative second power plus 5 to the t to the negative second power. It's probably hard to see that. I'm going to try and rewrite it with this white marker. Okay. So we said 10 t to the negative second ln of t, because the 6 and 4 come together to make 10, they have the same terms. And then we have a minus 10 t to the negative second natural log of t. And then we have minus 5, you can see a pattern here probably, minus 5t to the negative second plus 5 t to the negative second, and that equals 0. So, and we're seeing if that equals 0. Well, the 10t, the natural log of t, and the negative 10 cancel out. The negative 5 and the positive 5 cancel out. So we wind up with 0 equals 0. And that means that this second y2 of t is a solution to this differential equation. So thanks for watching. I will be back with I think I'm going to do separable equations next. So be looking out for that video. Thank you. Hey guys, I think I'm going to just end up tagging on this one problem to the end of that video that I just shot. So this is going to be the same idea. Last time we did y equals e to the rt. This time it's going to be t to the power of r. We're trying to figure out what values of r will make this a solution to this differential equation. So we have a second order linear homogeneous differential equation. Let's take, since it's second order, we'll take the derivative of this twice to get our y double prime. So y equals t to the r, right? So this will get a little more tricky than the last ones, but it's nothing that we can't handle. So y prime equals, well, you bring down the r using the power rule, right? And we're not using e, so we can't just leave it the same. So we have to do t to the r minus 1, right? You always subtract using the power rule, like without, when you're not dealing with e. So y double prime is going to equal r times r minus 1, because you have to bring this down now. So it's going to be r times r minus 1, and now it's going to be t to the power of r minus 2. So now let's try and start plugging everything in, see what we can and can't cancel. So t squared y double prime, which is r, kind of want to, I'll just leave it in the simple form. Actually, y'all, I hope you see this. What I'm going to do is I'm just going to go ahead and distribute this to make it easier. So this is actually going to equal r squared minus r times t to the r minus 2. Hope you saw that, just distributed. So r squared minus r times t to the r minus 2, right? That's t squared, this t squared, this is y prime, right? So, or sorry, y double prime. So now y prime, we have 4t, so plus 4t times y prime is r times t to the r minus 1, right? And we have plus 2y, which y is t to the r, so plus 2 times t to the r. We're trying to see where that is equal to 0. So now this might look like it's going to be a little tricky, but I really don't think it's that bad. We can take this t squared. So for instance, this whole term is multiplied, right? So since this whole term is multiplied, we have two bases of t, right? So what we can do is we can just, when you multiply, remember from algebra, when you multiply two of the same bases together that have different exponents, you can just add the exponents together, right? So what this is actually going to be is, so when you multiply t squared times t to the r minus 2, let me write that a little bigger. T squared times t to the power of r minus 2, what you're really doing is you're doing 2 plus r minus 2. And the 2's go away and you're left with t to the r. So those cancel out pretty nicely. So t to the r times r squared minus r plus, well, we have 4t and then t to the r minus 1. So let's combine these. T to the power of 1 times t to the r minus 1, which is going to equal 1 plus r minus 1. Those are going to cancel again. You're going to be left with t to the r again. So it's going to be plus 4t to the r. Actually, I'm going to do 4r. 4r t to the power of r. And then plus 2t to the power of r equals 0. So now we're going to have to solve this we're going to solve where this statement's true, right? Well, we have a t to the r in common each time, right? We do not have an r in common, so let's pull out a t to the r first to see if we can get it into a familiar form. R squared minus r plus 4r plus 2. Too many parentheses. Equals 0. So now what we can do is we can solve this for r, right? So let's do this negative r and this positive 4r, since I'm running out of room, I'm just going to rewrite it. So this turns into 3r, right? 4r minus 1r is going to be 3r. So I'm going to do this. Sorry, plus 3r. 4r, yeah, 4r minus 1r, yeah, okay. So plus 3r and then plus 2. So it's going to give us t to the power of r, which this will never be 0, right? Because it's not dependent. It could be 0 if it were dependent on t, like t would, I mean, when t equals 0, yeah, but we're looking at values of r, we're not looking at values of t. So this is going to be, factor it like this. So 2 and 1 will give you 3r, right? So if you have plus 2 plus 1, so that is r squared, 2r plus 2r plus 1r, which is 3r, and then plus 2 equals 0. So this is going to give you the two values, r equals -2 and r equals -1. And that is when when r is -2 or -1, this equation is going to form a solution with this differential equation. It's going to be a solution. So hope you enjoyed that video. Stay tuned. Thanks.